In the previous lecture, we have started studying about process synchronization, and we have seen how process synchronization is a very important part of operating system. So with regard to that, we will be discussing an important topic now, which is the critical section problem. So in this lecture, we'll be studying about the critical section problem, and this is something that is related to process synchronization. So keep in mind that what we mean by process synchronization is that when we have cooperating processes, we want them to be synchronized between each other in such a way that there will be no data inconsistency, but the data that we are having or the data that is shared between processes will remain consistent. So that is the main aim of this process synchronization. So with regard to that, we will be seeing what is this critical section problem and how is this critical section problem useful for process synchronization. So to understand the critical section problem, let us consider a system consisting of n processes with process IDs P0, P1 up to Pn. So we are having a system with n processes as given here. So each process has a segment of code called a critical section in which the process may be changing common variables, updating a table, writing a file, and so on. So what we have here is, in all these processes, there is a certain section of code which we call the critical section. And what is this critical section? The critical section is a segment of code in a process where the process will be changing common variables or updating a table, writing a file, and so on. That means whenever the process is accessing the shared memory and making some manipulations in the shared memory, then the code that is responsible for doing that particular operation is known as a critical section. So critical section is that segment of code of a process in which the process will be changing the data in a shared region of memory that is shared between different processes. So that is what we mean by the critical section. So now what we are going to do is, when one process is executing in its critical section, no other processes is allowed to execute in its critical section. That is, no two processes are executing in their critical sections at the same time. So when we discussed about process synchronization in the previous lecture, we have taken one example and we saw that when two different processes are simultaneously trying to manipulate a shared variable, then we ended up with inconsistent data. So in order to avoid that, we are going to make use of this critical section. So we have already understood what a critical section is. So it is that portion of code which will be responsible for changing the common variables. That means when the shared data is accessed, that section of code is called a critical section. Now, when one process is executing in its critical section, no other process is allowed to execute in its critical section. So different processes are having different critical sections. So when one process is executing in its critical section, what does it imply? It implies that it is making some change to the shared data. So at that time, we should not allow other processes to execute in their critical section. So what does that mean? That means that when one particular process is accessing and manipulating the shared data, no other process will be allowed to access and manipulate the shared data. So that is what we mean by this. So no processes are executing in their critical sections at the same time. So if this can be accomplished, then we can make sure that multiple processes will not concurrently try to manipulate the shared data. So now we can understand that the critical section problem is to design a protocol that the processes can use to cooperate. So we saw in the previous lecture that cooperating processes are the processes that are sharing the data. So when they are cooperating, they need to be synchronized. And what do we mean by synchronized? They should not try to manipulate the shared data concurrently, which will lead to data inconsistency. So the critical section problem is to design a protocol that the processes can use to cooperate and cooperate in such a way that they will be synchronized with each other properly. So that is what we mean by the critical section and the critical section problem. So we'll be discussing more about this critical section problem as we move ahead. So there are certain rules that has to be followed by processes whenever they are accessing their critical section or operating in their critical sections. So what are they? Let's see. Each process must request permission to enter its critical section. So every process must request permission to enter its own critical section. Then The section of code implementing this request is the entry section. So the section of code that will implement the request of the process to enter its critical section is known as the entry section of the code. And then the critical section may be followed by an exit section. So after the critical section is complete, then it will be followed by an exit section. And the remaining code is the remainder section. So our code is basically divided into these 4 parts. So the first part is the entry section, which is a section that will allow entry to the critical section. Then we have the critical section itself. And then we have the exit section, that is the exit from the critical section. And then the remaining sections which are not included in these 3 is known as the remainder section. So here is the glimpse of a code structure of a typical process. So let's see here. So here we are having a do-while loop. So inside this do-while loop, we are going to have the critical section and the remainder section. So first of all, we have the entry section, which we have just explained here. This is the section of code that is implementing the request of the process to enter its critical section. So the entry section is here, and then after this we have the critical section. So to enter into this critical section, we need this entry section. And then we have the exit section. So exit section is the section that follows after the end of the critical section. That means after a process completes its execution in the critical section, then it is followed by the exit section. And then the remainder of the code, the remaining portion of the code is known as the remainder section. So this is just a snapshot of the general structure of a typical process that we have. Alright, now since we have understood what is critical section, we will be discussing about some of the requirements that are there for the solution to the critical section problem. So a solution to the critical section problem must satisfy the following 3 requirements. So these 3 requirements that we are going to discuss now are 3 very important points that you should remember with respect to the critical section. Alright, so let's see them one by one and let's try to understand what they mean. So the first one is mutual exclusion. So what do we mean by mutual exclusion? If process Pi is executing in its critical section, then no other processes can be executing in their critical section. So this is one of the very obvious things with respect to critical sections. So we have already explained in the beginning that when one process is executing in its critical section, no other processes should be allowed to execute in their critical sections. That is because the critical section is the portion of code that is modifying the shared data that is shared between different processes. So that is what we mean by mutual exclusion. If a process Pi is executing in its critical section, then no other processes can be executing in their critical sections at that point of time. So that is mutual exclusion. Now the second requirement that we have is known as progress. So what is this progress? If no process is executing in its critical section and some process wish to enter their critical sections, then only those processes that are not executing in their remainder sections can participate in the decision on which will enter its critical section next, and this selection cannot be postponed indefinitely. So what we mean by this is that, let's say that at some point of time there are no processes executing in their critical sections, and at that point of time 2 or more processes wants to enter the critical sections. So it says here some processes wish to enter their critical sections. Then the question here is, which of the processes that wants to enter the critical section should be allowed to execute in their critical section? Because we know that only one process can execute in their critical sections at one time. So which of the processes that wish to enter the critical section should be allowed to execute in the critical section? Then this decision of which process should be entering the critical section can be taken by only those processes which are not executing in their remaining sections. So we have discussed about this remainder section. So remainder section is a section that is not the critical section, not the entry or the exit sections. So the remaining section of code, that is what we mean here. So only those processes that are not executing in the remainder section of their codes can participate in the decision making process. And what is the decision making? We want to take the decision of which among the processes that wish to enter the critical section should actually enter the critical section. So in this decision making process, only those processes which are not executing in their remainder sections can participate. And also, this selection cannot be postponed indefinitely. That means when multiple processes wants to enter the critical section, the decision of who should enter the critical section should be taken without causing much delay. We should not postpone it indefinitely. The decision must be taken without delay. So that is what we mean by this final line. So this whole thing is known as progress. So this is another important requirement of the critical section problem solution. Now the last requirement that we have is bounded waiting. So let us try to understand what do we mean by bounded waiting. So it says here, there exists a bound or limit on the number of times that other processes are allowed to enter their critical sections after a process has made a request to enter its critical section and before that request is granted. So what we mean by this is that we will have a limit on the number of times that other processes are allowed to enter the critical section after one process has already made a request to enter its critical section and before that request is granted. So in this progress, we saw that this thing can happen. Some processes wish to enter the critical sections. Okay, so let's say that some processes have requested to enter the critical section. So we don't know at this point that which process is going to get to execute in its critical section. So let us consider one process here. So let's say that one of the processes have already made the request and the request is not yet granted. And some other process which has also made the request is now allowed to execute in its critical section. So the decision of who should execute will be taken by whom. We have discussed that in progress. So we see that in this case, one process has made the request and it has not yet been granted. So in this kind of a scenario, there will be a limit on the number of times that other processes are allowed to enter their critical section. So one process has already made the request and it is waiting to get the critical section. So when it is waiting, there must be a limit on the number of times other processes are allowed to enter the critical section. So why should we have this? We should have this because if we are not having this kind of a thing, even in this critical section, we may face something like a starvation. A process may request to enter in its critical section, but other processes are keep on executing in their critical section and the process that initially requested is not getting it. So that is why we are having this bounded waiting. So we will have a bound or a limit on the number of times that other processes will be allowed to enter their critical section if one process have already requested to enter its own critical section but the request has not yet been granted. So that is what we mean by bounded waiting. So these are the three requirements that we have for the solution to the critical section problem. These three requirements must be definitely satisfied and only then we will be able to have a solution to the critical section problem. So we see that critical section problem is something that is used for synchronizing processes that cooperate with each other, and in order to solve this problem we need to satisfy these three requirements. So this critical section problem is a very important topic as far as process synchronization is concerned, and I hope this lecture about critical section problem is clear to you. Thank you for watching and see you in the next one.